Alright, in the last video we created persistence on the server side for the agent, and now let's see if we can get some movement out of it. So we said before that probably the leader should be responsible for creating each agent. So we kicked off the start spawning, which is only run by the leader, and start spawning has some logic that will just go and create. So right now we're only creating one new agent, and maybe this can, it's not necessarily just start spawning, it's also getting it to navigate everyone. Maybe we'll just make another function, say navigate all, or plan movement for all agents. And we have a list of agents. It's this agents for each. So agents is a list. Yes, I think it is. We get an agent, and this thing is no, it's an object. Agents is an object. Oh, okay. You can also do object keys for every agent in here, for each agent name. Let's check the API. So we can get a random world position inside a circle of max radius. Okay, let's try this. So this nav, do we have access to the plugin? We have access to the crowd, but I think, okay, we have the scene. I think we also need the plugin. Let's go to the nav manager. On client ready, you pass in this navigation plugin, and the type of this is Babylon Recast.js plugin. Okay, so we have the plugin here. This plugin dot get closest point, get default, get random point around agent position. So I need to get the agent back. So const agent is this agent's I don't know where they are. I have to use the crowd to get their position. This crowd get agent next target path, get agent position for this agent's agent name. Right, this takes the index, so this gives you a position. So you get a random point around this position and a max radius of, let's say, 3 meters. Const new position. Then maybe you can emit a new message, which is agent move to. So we need a new type. We have that an agent was spawned at a certain position. Now you can say agent directed to. Let's create the event name first. Let's say it's agent directed. So the message is agent directed payload concerning the name of the agent and the current position. Why do we need the current position? Because we can update the state for anybody coming late. That will help a little bit. Current position and the new position. Next position. Let's call it the next position. Actually, is that what we get though? this gets a random point, but then we need a path, don't we? That's when you get this crowd get what? Get the next corner points composing the path. Add agent, agent go to, agent teleport, agent next target path. Guess the next target path. Velocity. Let's look at the, let's see what we have here. Get closest point, dashed lines. You can update an agent's parameters. That's interesting. Is there like a get path though? Well, this just sets the position. It's not a linear thing. We're going to have to say go to, and it will calculate a path around that point. It's not a linear path, so I guess that's fine. This is just saying next target. You're directed to the next target. So yeah, this is a new position. Let's just emit this. Alright, so the const payload becomes a type of event. And the message is event name dot agent directed. And the payload is what's the payload here? Name, agent name. Current position will be the position, and next position will be new position. Well, we'll just call these the same. Next position, and current position, current position. Oh, so this is a vector 3, this is a vector 3, and this needs to be to array. Or as array. As array. This gives you the event, and then you'll emit it going outward. payload. And we'll do this periodically. So let's just say set interval. It's very naive right now, and we'll just do this every 5 seconds or so. I'll take the whole of this, cut this, put it inside this function. So every 5 seconds, it's going to send a message about where to go next. And let's, got errors here. Clear. Agent manager. Oh, I need to save this. Agent manager. Okay, we're all good. Okay. Let's check it out on the front end. Oh, yeah, we need to call this. So plan movement for all agents. And we'll do this here. We say start spawning, and this nav manager, agent manager is plan movement for all agents. Okay, so we've got some stuff here. Next position, -6 something, -6, 18, 3, 1. Okay, it looks random. It's basically randomly moving around. Now we need to receive that message. Let's receive this message in the agent manager. Alright, so this, let's write some comments. Creates any previously created agents. Creates newly spawned agents. And move agents. So signal hub incoming on. We won't get our own event back, right? So if we send this out, we have to send it to ourselves as well. Outgoing and incoming. Event, and we'll pipe it through agent directed. Subscribe. Here's the event. What do we want to do with the event? We want to event dot message payload. Don't know what kind of payload it is. Kind of sucks. But we want the name, current position, next position. So name, this is the const agent index would be this agents that. Okay, and now we want to move it. So this crowd agent go to agent index, and the destination, let's say destination equals event payload new next position as a Babylon vector 3 from array. That's the destination. And that should get it going to the random position. So we're loading the server to visit the space and become its leader. In 5 seconds, the leader is created. Okay. Every 5 seconds, it will randomly move to a new position. And for the test, we're going to open up Firefox and go to space as well. Now, I'm not the leader, but as soon as I connect, I'll get any previous. But I hadn't updated the position here, but that might not matter because it will eventually catch up, I think. So they want to end up in the same place. And then they start moving according to the same rules. Pretty cool. Let's add rotation into the mix. I think I had some rotation here. Agent velocity, you could use this to turn it. So when we're receiving the new message, we go agent go to. Actually, how did they do it? How did they do it? Did they do it on every frame? Velocity, you get the velocity. If velocity length is greater than that, desired rotation. I think the way they did it, example of agent orientation and next path targeting. I think they did calculate it on every frame. Yeah, on before render observable for all of the agents. We got their mesh position, and you updated their mesh position. Crowd get agent position. With their velocity. Again, the agent next target path to reference. Velocity normal desired rotation. And okay, I think we just need to register this once. And everybody needs it, not just the leader, because we all have to rotate it, so it needs to be in agent manager then. So we'll have to do it according to this list of agents. This scene on before render add agent count becomes object dot keys. Why don't we just do the values? This agent's object values are all the agents, and just do for each, and this is the agent index. Now I think I can get the position, agent velocity, and agent next target path. Then you have to have access to the mesh. I see. So when we created the agent, what did we save? When we created the agent, we have this transform, but this agent doesn't really have it. Why don't we just create a list? I think I like working with an array better. So let's say that the agent can be the name, and let's say it has a name, it has the agent index, which is a number, it has the mesh, which is a Babylon dot abstract mesh. If we look over here, mesh, ag mesh, and this comes from agents. And what is agents? Agents, empty array. When are you setting agents? Agents.push. Okay, agent index, transform, mesh, and the target. Target cube. What is target cube? Oh, okay, it's just illustration. Okay, so they're saving the transform too, so we can save the transform. Mesh, transform, Babylon dot transform node. Okay, so that's what an agent is. Name, blah, 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 and it's a list of these things. And in the beginning, it's an empty array. Okay, then when you create an agent, the enemy here, this will be the mesh, const mesh, const transform, mesh, parent is transform. Okay, let's let it be let. And that's the agent index. We have the transform. Then this agent's push new object, which is name, which is the agent name, the mesh, which will be the mesh, the transform, which will be the transform, and do I have anything else? Index. Agent index is the agent index. Actually do it like this. It's a shorthand. And then when we want to delete the agent, we can just remove. So, okay, removing is a little harder. You got to find the index. So you just say, well, the case hasn't come up where we need this yet. Defer that for a moment. Come to this red. Okay, here, move the agent. Move agents. Move a particular agent. Okay. Yeah, that's where having it in an object is easier. Because then I can just have the name point to all of these things. So if we did this, and you have this, name points to this. Now it's an object again. Name string. Okay. Once again, empty object. Go back to the create. So it'll be agents agent name equals that stuff. Then this is still good. Agents, agent name, and agent index. Over here, we want to set plan movement. We need the agent index, agent name, agent index. Good. And up here, if we're receiving the new position and moving it, right? So we're saying agent go to, we need to get the agent index, which comes from the name dot agent index. Right, and then finally we gotta fix the rotations for everybody. This gives you the agent object for everybody. So we can say that the const position is this crowd get agent position from agent object dot agent index. Why don't we just save this out? Const agent index equal velocity const velocity equals this crowd get agent velocity with agent index. Then we get the next target path reference. This crowd get agent next target path to a reference. Pass in agent index and you're saving this into a new position. This is not necessary. This is only to move that target cube so that we can see where you're going to. We don't really need this. And this is a piece that we need. Velocity length greater than 2. Velocity normalize. So this prevents us from going too fast, I suppose. The desired rotation becomes math A2, velocity x and velocity z, and then we modify the rotation. So agent object mesh shall be updated in this way. Alright, here's the previous thing. Looks like we've got 2, and they are rotating. Interesting, they're like resetting every once in a while. It's interesting. Since they both get updated at the same time, they're in synchronization for their turning. And let's pull in Firefox, take a look. Oops. I thought that was an overlaid menu. Okay, one thing we can improve is the initial position of the agent. So when we're receiving this message in the space server side, we can process this message that we are getting in event here. If the agent was spawned, modify the state in this way. I think we can maybe abstract this out into a function. Instead of calling this choose leader, why don't we say agent spawned. What do we call this handle event? Handle cast, handle cast. We call this handle event specifically, so that the rest of this stuff, all the stuff you want, handle broadcast, then this stuff will do in the handle cast. Defined handle cast, and if this one was member entered, Then we'll do handle event and pass. This is the tuple. The tuple and the state. But first, in the choose leader business, we're gonna do this. Copy. And coming back to our handle cast. So when member entered, we'll do this. What happened here? PID is unused. Yeah, PID is unused. Then we'll do the same thing for member left. So I don't think we need this one. Let me say member left. Copy. Def handle cast event member left event and PID. Yes, this is a tuple and state and do and bam. And then we pass handle event here. So up in the generic form of handle event, we don't need to choose the leader anymore. And then let's also move the save agent business out of here. Define handle cast event agent spawned event PID that's equal to tuple state, and then we're already down this path, so if it does match, you just need to say state is this now. Agents is a list. And we might want a an object of agents. It makes it easier to delete them. Yeah, we can say agents is something else. Yeah, let's do that. In the OK, in the init, let's just create a new map. What is map set again? Elixir map set. What's the API? Well, they're unique. New. With different elements, and then you can put. I don't think I need a map set. Member entered and spawned. Here, let's just do map dot put into state agents. The key will be event name, and the value will be oh, I see. You can have some redundant storage in there if it's the key, and then you also want to send this and that. Heck, list is fine. Just use list. Okay, we're sending a list of this and that. That's fine, and then just handle the event, the tuple, and the state. And over in the generic one, handle event, we don't need to do that. We always increment this, send it over to save the business, and broadcast that to everyone if needed. Broadcast event. All right. So then what? Let's test it. Okay, something broke. No function class matching spacer handle cast where its member moved. Oh yes, we need a catch-all. Handle cast for member moved. It will be the bottommost one. Sorry. It'll still be next to the events. Def handle cast with event and some message something, and that's a tuple, and this is the state, and then we'll just send handle event with the tuple and the state with no interception. What happened here? Handle cast agent directed. Sure. That's an old message, right? Let's do a clear. And oh no, we're still getting here. Let's just restart clear. Okay, we jump open here. Nobody has an agent yet. In 5 seconds, we'll create an agent. It's getting directed to, and no errors. Open up our Firefox. It struggles to catch up. Now it's finally in sync. So when we get the agent directed, we can update our information. Let's do agent spawn is this. Agent directed. We're going to say that the state is, and then we're going to updated agents. And so we want to get filter so enum.filter state agents. Go through each one of the agent, and I only want, no, I don't want to filter, I want to map over them. I want to map over them, and the result of this would be the updated agents. As I map over them, I can check something. I'm checking if agent, and we can look over here, if agent name is equal to event.payload name, that's the one I'm talking about, and that's the one I want to update. Otherwise, pass over it and return agent unchanged. Excuse me for a second. Where was I? Right. We gotta update the entire list. So if we have a match, we are going to return the new agent, modifying the position parameter to be event next. No, it's not there yet. It's current position. I mean, it's the thing we know. It's not perfect, but it'll, at least I think it will be accurate when the command was generated and be immediately outdated. But as somebody loads the site again, so if we just do this over again, we will run this one. So as it gets a couple of redirects, assuming this doesn't break over here, we get next position, next position, oh what? This is loaded in already? Let me close that. Okay, so this should be updating something. So then when we load new Firefox, it shouldn't be at the origin. It'll be somewhere over here. Whoops, I clicked on observe, but yeah, I mean, it was over here. Let's try it again. Close this. What happened? What happened? Cannot read wait, what is that? Cannot read properties of undefined reading nickname from member states. Okay. Firefox. Local host. Enter. Okay, sort of. Okay, I think we can safely say we've got server coordinated joint enemy experience now. A slight tweak to this, and we'll make more tweaks to this, is that the agent manager is to support mesh rotation. Yeah, that function where we're just coordinating everybody. We don't have to coordinate everybody at the same time. You can find one of the agents, right, for each, and then maybe randomly select one. That way you're not, and then it doesn't have to be on a set time. So you could do one timeout and keep changing the time interval between of when it gets triggered. But we'll save that for another day.